All right, you guys, let's go ahead and get started here. We want to go ahead and do lesson 5.7 here. We're doing explicit formula and geometric sequences. So let's go ahead and get started here first with the formula, guys. Once again, this here is the formula for explicit form. All we need whenever we're writing the explicit form of geometric sequences is our first term and our common ratio. So in this case, guys, we're going to go ahead and do, once again, it could g of n equals g of 1, which is going to represent our first term, times the common ratio to the n minus 1. All right. So let's go ahead and get started here with example 1. And in example 1, we want to go ahead and find the explicit formula for h of n. So once again, we're going to go ahead and be writing our explicit form of the sequence. Now, in this case, guys, they're giving us h of 1 equal to 6.4. H of 1, in this case, guys, is going to be equal to our first term. And in this case, guys, the 12 is going to represent our common ratio. So in this case, the first term of the sequence is 6.4, and the common ratio is negative 12, which means that each time if we're moving from one number to the next, we'll be multiplying the expression or the equation by negative 12. So let's go ahead and write our formula here. In this case, we're going to go ahead and have h of n equal to our first term, which is 6.4, times our common ratio. And in this case, guys, if you're working with negative numbers, I do recommend for us to write the common ratio in parentheses, just because we are raising it to the exponent of n minus 1. So we are including the negative value in the equation. And in this case, guys, that would actually be our final answer. Now, once again, there are two ways to express this. This is one way. Another way we could express this is we could actually distribute the exponent here. Since we have a base of negative 12, we could actually distribute that to write it in a different form. So, for example, the 6.4 here doesn't change. So h of n equals 6.4 times negative 12 to the n times a negative 12 to the negative 1 power. Now, in this case, guys, with the negative 12 to the n, that nothing's going to change there. But in this case, if I do negative 12 to the first power, negative 1, let's see, parentheses, negative 12 to the negative 1 power, that's actually going to give me a negative 1 over 12. And in this case, guys, whenever you have negative exponents do tell you to flip. So this would actually become, let me move this, h of n equal to 6.4 times negative 12n times 1 over a negative 12, or in this case, negative 1 over 12. Okay, now we do have to simplify this here by combining these. So I'm going to go ahead and multiply, in this case, 6.4 by a negative 1 over 12. And in this case, that will be giving us the fraction of a negative 8 over 15. Or if we wanted to use decimal, then we would be showing that as a decimal. So, but I'm actually going to go ahead and keep the fraction because our decimal is non-ending. So, in this case, I could do h of n equal to negative 8 over 15 times a negative 12 to the n power. So it could also be this one here. All right, and in this case, guys, like I said, I am using a fraction just because it's more accurate. But if you do have an ending decimal, maybe 2 decimal places or 1 decimal place value, go ahead and use it. So once again, that was the first example. Now let's go ahead and take a look at example 2. In this case, guys, we are given a formula or explicit formula, and they want us to find the recursive form. If they're asking us to find the recursive form, all we need to do in this case is identify the first term and the common ratio. So in this case, guys, if I want to go ahead and find my first term, I'm actually going to go ahead and substitute a value for n, or I could actually easily identify it. But safest way for us is to actually substitute a 1 into our equation. So if we want to find f of 1, that's going to equal 45 times 4 over 5 to the 1 minus 1. So this becomes 45 times 4 over 5 to the 0 power. Now, in this case, guys, anything raised to the 0 power, anything is going to be giving you a 1. So if I input this in the calculator, parentheses 4 over 5 to the 0 power, our result here is a 1. So f of 1 in this case equals 45 times 1, which in this case is just going to be 45. Now, you're going to say, why do I have to do all this work if 45 is there? In this case, guys, it is. If you see, in this case, your exponent is n minus 1, you could easily identify your first term as being the number being multiplied next to the ratio. But if you just see the n in this case without the minus 1, the number appearing there won't be your first term. So here, I'm just going to write 45. And common ratio in this case, guys, is the number or the base with the exponent. So that's going to be 4 over 5. All right.